synthesis, absorption, and metabolism of provitamin D. The vitamin D family includes a number of compounds, all of which have vitamin activity. The most important compound found in animal sources is vitamin D3, often called cholecalciferol. Plants contain small amounts of the provitamin ergosterol. Ergosterol can be converted into vitamin D2, which differs only slightly from vitamin D3 and has the same vitamin activity. Strictly speaking, vitamin D is not a vitamin that we have to acquire from foods, since under favorable conditions, sufficient amounts of it can be produced in the body during sun exposure. The 7-dehydrocholesterol made from cholesterol is converted to provitamin D3 in the skin under UV exposure, which turns into vitamin D3 under the influence of heat. In foods, vitamin D3 occurs in animal sources in its free form as well as linked to long-chain fatty acids. Before being able to be absorbed, these linkages have to be broken by an enzyme called lipase, which is secreted from the pancreas. This occurs in the upper part of the small intestine during the digestion of dietary fat. In plant-derived foods, vitamin D2 is usually present in its free form, but only in low amounts. Free vitamin D2 and D3 are absorbed by the intestinal cells, and because these are fat-soluble molecules, are transported to the liver in chylomicrons, similarly to retinol. To be biologically active, vitamin D2 and D3 first have to be converted in the liver and then in the kidney. In both tissues, a hydroxyl group is added to the molecule, which results in products that are more water-soluble than their parent compounds. Nevertheless, all free vitamin D metabolites are transported in the blood by a specific vitamin D binding protein called DBP. Hydroxylation in the liver occurs at carbon atom 25, and this yields the intermediate 25-hydroxy vitamin D, also called calcidiol. This is transformed into the active form of the vitamin by further hydroxylation in the kidney at carbon atom 1 to 1,25-dihydroxy vitamin D, or calcitriol. The active vitamin D reaches its target organs through the bloodstream, where it circulates mainly bound to the vitamin D binding protein, DBP. The last metabolic step, hydroxylation to 1,25-dihydroxy vitamin D, is strictly regulated. The presence of active vitamin D inhibits its own synthesis, but stimulates its own degradation. Parathyroid hormone and low phosphorus levels activate the hydroxylating enzyme in the kidney. A multitude of additional factors exert their influence, mostly indirectly, via parathyroid hormone, calcium, estrogen, glucocorticoids, and calcitonin, among others. This tight regulation permits short-term adjustment depending on the calcium and phosphorus needs.